Hi, I'm Dustin Berg with ProAVSchool.com. In this video, I'm going to show you how to create on a Crestron touch panel a way to save presets or text basically in non-volatile or NVRAM. And basically what that means is it will hold its values if the processor reboots. So basically this is a way for users to edit the names of their presets and it will stay if the processor loses power or whatever. Now one thing I should note before I get into it, keeping variables stored in NVRAM and serial text in NVRAM is probably not the best way to do it. There's better, more advanced ways using the file system. The reason I'm showing it this way in this video is it's probably the simplest way to just put something together. So if your requirements are very simplistic and you don't have like multiple rooms where you might want to load this stuff from a file or transfer it to other processors and stuff, this is probably the easier way to do it. Comment below if you want to see some more stuff about file system access, and I'll consider posting some videos about that. But that is outside of the scope of this video. So right now I'm just going to show you with my X panel here what we're building. So there's 8 presets. They all have a name. I have only filled in the first one for now. These other buttons don't do anything. But the way that this works is when you hold that down, when you press it, it will recall a preset, which I don't have any logic connected for that. So assuming it's for like a camera or something. But when you hold it down for 3 seconds, it pushes this name to here. And from there you can edit it, save it. It'll pop up and say preset stored. But then that's actually stored in non-volatile RAM. And I'll show you after we look at the code and stuff, I'll show you how it's actually stored, that you can restart the processor or restart the program and it's still there. So let's jump into what we're doing in simple. So the heart of this program is this symbol called serial RAM. And for what we're doing, we're using it in a very simplistic way. There's a bit of a trick to it. Normally I use F1 a lot to look at new symbols or symbols that I don't work with a lot and try to understand them. Some of this help information is a little bit dated and it talks about things kind of in the context of older ways of doing things, system builder and stuff like that. And at this point in time, some of the stuff that it's talking about doesn't even really make sense to me. But the important thing is it doesn't really explain specifically how you're supposed to use it. So let me do that right here because I had to play around with it a little bit. So there's a store and a recall input. There's this in and out string, that's your serial data. And then there's this select. So you can use this serial RAM to have multiple slots. And the way that I'm going to do it, just to make it easier on myself, is probably just have a separate serial RAM symbol for each preset position. I'm going to experiment with that after I pause the video because I'm going to fill in all the others. Right now I just have the logic here for the first preset. So what you need to do is, to make the symbol work, is you press store, or you hold the store input high or the recall input high, and while that's happening you press the select input. So the logic inside here is doing some funky stuff. So that's the order that you need to do it in. You can do it pretty simply by basically just having an OR. So memory store, memory recall, whenever one of those goes high, memory select 1 will go high momentarily and it will push it through. So that's the easiest way to use this symbol. You also need a make string permanent tied to your serial text. Now these other ones are red because I haven't connected them yet. So that's how the actual storing is happening. Now it needs to be near the top or the very first section of your program. And the reason for that is if you're making changes to your program in the future, you want to be able to change and add stuff and recompile and load it, but have it not wipe out your NVRAM. And the reason that it works when it's near the top, and I'm not 100% sure on this, but I believe that is because the way that the simple file is actually organized, new stuff is added to the bottom, so it changes around the memory allocation and stuff, but it doesn't affect things that are near the top that have already been kind of mapped out a little bit. So I shouldn't go too far with that because I don't totally know how it works underneath the hood, but I do know if you're using serial RAM or like NVRAM for analogs or serials, you want to keep them at the top. Now, the other things that we're doing in this program, it's a pretty basic program, but it took me a little bit to put all this together. The trick is that you're pushing around serial strings, and you can't just use the serial buffer. The problem with the serial buffer is it won't propagate when you enable the gate, like a digital might, or like the serial analog buffer will. So I'm using exclusively analog buffers here. They're actually serial analog buffers, and they'll pass it through, they'll pass values through when the enable input on the signal, on the symbol goes high. So I'll show you that in a second, but what I want to do here is when you press this, there's a press and hold, so I need a symbol for that. It pushes this text to this variable here, and that's what's feeding the keyboard module. Then it's modified. When you press save, it has to push this text back to the stored preset. And that's what it does kind of behind the scenes. So taking a look at what we've got here. So your preset press, like I said, it goes into this press and hold. Hold for 3 seconds. Output pulse time is just 0.1 seconds. And I haven't connected the press not held. This is what would actually drive your preset recall. If you're recalling camera presets or whatever, this would drive your other logic. So that's not even being used for this demonstration essentially. But this press held is what's interesting. So this will go high after this is held for 3 seconds. And what we're doing with this, first we need an interlock. And this interlock is holding which one of these you pressed, because we'll need that when you store it to know what position to put it into. The other thing we need is the analog buffer, and this buffer, it would be a serial buffer, and like I explained why I'm using the analog buffer. When this goes high, when this enable join goes high, it pushes this through to this. So that keyboard text, the way that serial strings work with a module like this is it kind of backfeeds into it. So that basically lets this module update the text. Let me just show you kind of how that looks. So it pushes this in here, and then anything you press on this side gets added to the string at the end. Or you can backspace or clear it. So we've basically got just the keys, and I didn't put numbers and stuff. You can spend a much more time. You could have also used a keyboard input type in Vision Tools Pro E. I don't usually like using that just because I can't control how it looks. It's kind of rendered by the underlying operating system of the touch panel, and also, importantly, I can't simulate it on an X panel, and I like to be able to simulate things because I don't keep a lot of hardware in my office. So this keyboard text, the next thing that happens with it is it's sitting here waiting at an analog buffer to be stored or sent to a specific slot. So in this case, I only have the one slot. So when this preset store to one condition goes high, then it pushes it back to preset one name. And let me just show you where we got that condition from. So the store operation here, to store to RAM, we're going to need a bunch of AND symbols basically. So when that store press goes high, so that's the save name, and the preset to update, this is from that interlock, it's the one that you picked. When preset 1 is high, then we're going to go preset store to one condition. If I was to build this out and I'll do that kind of behind the scenes here, but just copy, I could probably paste increment actually, Control Shift V, and I'll just do 1. And store to preset 2. And I haven't filled all this stuff in yet, but that's how that would happen basically. So then you've got you'll have these analog buffers. I'll need a bunch of these analog buffers as well for all the different preset names so that it's pushing the keyboard text to the right preset name. Now the other thing that happens when you press store is, there's actually a few things that happen. There's a one shot, and this is that pop-up. So this is what you see when that drives this basically preset stored page, subpage. But also I'm trying to find where I put this here. The actual store operation. So let me find it here. Store to one condition, buffer. Let's let me look at my RAM here. So memory store comes from oh yeah, I called it test because I was playing around with that symbol. That's why I couldn't find it. This is actually supposed to end up here. Store operation. Let's keep it clean. I'm gonna give a copy of this below the video, that you can download this this project so you can play around with it. So preset store.press, that's the press of, I'm just bringing it up here on the other monitor. That's this here. That goes to memory store. So memory store is holding this high, but then it's also feeding the OR, which will select 1. So I'm kind of assuming that this preset 1 name.txt is going to be there when this happens, and that's probably based on the length that you actually hold your finger on the button. So if you're going to be super advanced about this, you might want to work at some timing, maybe logic delays or something like that, to make sure that you wait for there to be a valid signal here before you try to save it, because otherwise you could find yourself in a condition potentially where you're writing a blank string to that preset name just because it doesn't get through there. The other way you could do it is just put a delay on preset 1, preset store 2 condition. Or actually, you could delay this. You could delay the preset store press if you find you're having problems. This works fine in my test environment here, so I think it's probably okay just for what it's doing. But timing issues like this, it's this concept of code smell, and I talk about that in the TLDR method course. You can check out tldrmethod.com. I'm launching that probably mid-May or possibly early June. It's a pretty good course that goes through intermediate to advanced Crestron programming and simple programming techniques to really get you to the next level with your programming. But with that course and talking about logic wave delays and stuff, the problem potentially happens when your program gets more complicated and more stuff going on. If you just slam this into a more complicated program where there's a lot of load on the processor, the timing might get screwed up because of the load on the processor, and what worked here might not quite work. So the concept of code smell that I just touched on is stuff that it works, but it's not necessarily the best way of doing it because it doesn't have scalability in mind and portability in mind. So it causes you problems down the road. So that's something that I try to avoid when I can. But if I know it's going to be just a simple thing, sometimes I just go with it because that's kind of what happens sometimes with simple windows. So all that to say, you've stored it, and then it's basically in memory. So that's really all you need to do. Now, the other thing that happens is on boot, I have just a short delay, and then I have the memory recall. So I'm pulling everything from memory at boot. So let's just show you an example here Let me find my debugger window. I have 3 monitors on my computer here. Okay, so I'm just going to reconnect here. So I'm not going to actually restart the processor. I'm just going to restart the program to show you that it's stored basically. So we've got this symbol here, or signal here. What I'm going to do is manually just change it, just for fun, so we can show for sure that it comes back and it pulls it. So then from a console here, program reset, prog reset minus P1, that'll restart the program. And the first thing it's going to do with that initial stepper is it's going to recall from memory. And there we go. So that pulled that from NVRAM. So I'm just going to pause the video and I'm going to go through and finish off this program, and then I'll come back and show you. Okay, so I'm back, and now I have my additional presets added to the program. The Control-Shift-V to paste an increment works pretty good if you have your signal names planned out properly. So I was able to do that fairly quickly. For you guys, it was actually no time at all. I just paused the video, but yeah. So going back to it here, I said I would look at using one serial RAM signal and just expanding it out, and that would actually work. The problem is I kind of ran out of time with my demo to rework some of the logic, because that would have changed how I was doing some stuff here. And because these preset names are per slot, where I wouldn't have to do that if I did the select, but I'd have to do a few things differently. So you might want to experiment with that. Again, you could take a look at this code and see maybe you want to use it for yourself. And what I basically did is I copied these out. So I got a bunch of these, one for each slot. I had to copy this part out, and this part down here I had to copy out. You've already seen it all, so I'll just show you quick. One of the interesting things, because I left this here at the top, when I loaded this program, the first thing that it did was basically load my preset. So I had this from before. So that's pretty cool. But you can just go in there and edit them, and you can restart the program and see that it reloads. Actually, before I do that, we'll clear out the temporary text. I just got to reconnect here. Not doing anything fancy, I'm just putting blanks. I mean, I could just do it that way too. I just want something that's different so that when it boots up, I just don't want the X panel to have held the values from the previous run. So now when I restart it, prog reset minus P1, when that comes up, it's going to pull all those values that you saw before there. So let's give that a second. Interesting to note, I've been playing around with the MC4. Runs a heck of a lot faster, restarting and stuff. So I think maybe I should start doing my videos on the MC4 just because it takes less time waiting. Okay, so that pulled it up. So yeah, below the video here, I'll give you a link that you can get the project, the XPanel VTP, and the source for the simple here. So you can play around with it and hopefully use it in your projects as you see fit. And before I let you go, I just want to again mention that tldrmethod.com. Check it out and sign up to be notified when it actually goes live again. It's a really good course for intermediate to advanced programmers. I'm also working on a new bootcamp for more beginner to intermediate level people. It's going to be a live 4 or 6 week kind of session. That's going to be really good for people. I don't have a place to sign up for it yet, but you'll expect to hear more about that in the coming weeks. So thanks for checking out this video. And again, I'm Dustin Berg with proavschool.com. You can check out learn.proavschool.com for a bunch of the courses that we've got available on mostly on Crestron programming. All right, we'll see you in the next video.